is our setup for our Grignard reaction, and it looks pretty complicated, right? There's a lot of pieces of glassware connected to each other, and we're gonna break it down and talk about the function of each piece in this setup. Okay, so first we've got our 50 ml round bottom flask, and I've got my star bar in there already. And I've got this curved adapter that allows two different fittings on it. One is going to be for our separatory funnel so that we can do a slow addition, and the separatory funnel will do our work for us, so we don't have to sit there and add a solution dropwise. So we'll set that. And then on the straight edge of the curved adapter, we've got our condenser that will work to cool any vapors that are a result of our exothermic reaction occurring down here in our round bottom flask. And this reaction is also very water sensitive, so we want to add, up at the top here, we've got a drying tube. And in here we've got a substance called Grignard, and that Grignard basically works to prevent any water from coming in through the top of the vessel into our system here. So you see we've got an open end on our condenser, and our drying tube is just going to sit right on top. But if any moisture tries to come in, this Grignard is going to catch it before it enters our system. In our condenser, after we flame dry our system, we're going to add rubber tubes or rubber hoses that will allow cold water to come in through our condenser and out into the sink. And it's just going to cool this outer tube here. Okay, so there's not actually water going into the system. There's a water jacket that's going to just cool any vapors that come up through the middle inner tube. So we know that we're going to add magnesium to our alkyl halide. In this case, it's going to be to our bromobenzene. And so we first want to make sure that our magnesium looks good. Coming straight out of the bottle, our magnesium is going to look kind of dull. So let's take... So you see it kind of looks like a dark gray first coming out. What happens is as magnesium metal sits out into the air, the oxygen around in the air is going to oxidize our magnesium and form oxides, essentially magnesium oxides. So what we want to do is we can activate our magnesium and bring him back down to magnesium 0. Currently the gray dull stuff around it is magnesium 2. So we're going to bring it down to magnesium 0 in two ways. One is by physical method, where we're going to grind him up, and we're going to expose the shiny magnesium 0 surface so that is the material that reacts. So we need to expose that first. We're going to fluff off all the dull gray stuff. And the second way is we're going to add iodine. And iodine can chemically reduce him back down to magnesium 0. Our magnesium and our iodine to our flask. We just also want to grease lightly the joints that will eventually experience hot solvent passing through it. So I'm going to quickly disassemble a portion of this system, and since this joint is directly attached to our round bottom flask, I know that any solvent that heats up will definitely see that joint pass through him. So I can just grease him right at the top and just twist a little bit to make sure to get a nice tight seal. This prevents any solvent from escaping the system. And we don't technically reach our condenser until, come up a little bit, until this joint, okay? Just right below the condenser here. So this joint, called brown glass, also sees and will experience They're going to cool back down, so we're good after that. And I'm not going to worry about greasing the separatory funnel ground glass joint, because hopefully most of the vapors are going to go through this vertical portion of the curved adapter. Rubber hosing to our condenser, and of course let our round bottom cool before we add that ether solvent. My round bottom's still pretty hot, so I'm going to keep letting that cool. But in the meantime, I put my rubber hosing on the condenser. So you can see I've got my cold water tap, and that hose goes into the bottom of the condenser. And the reason we've got the water going into the bottom is so that the whole thing can fill up before it empties. And we've got that emptied into the sink. I'm going to slowly turn on my cold water tap, and I don't need it to go really hard. I just want it to slowly fill my condenser, and you see it go all the way up and funnel into the sink. Next, we're going to prepare a solution in our separatory funnel, and this is going to work to give us a way to do a slow addition without having to do it manually. So I've just added 2.25 roughly of our bromobenzene, and now I'm just going to put it into solution with roughly 5 milliliters of our ether solvent. Just quickly take it off and give it a little shake so that it all mixes in. We have a nice homogeneous solution. I'm just going to add roughly like a fifth of this solution, and I'm going to add that fifth fast. I just want to get some of our solution into our round bottom flask, and we're going to wait for initiation. That initiation will come in the form of a color change. So we should see that yellow start to disappear. We might start to see some cloudiness, and we're hoping for an exothermic reaction to occur. So we should see bubbling and fizzing occur, especially because even with just the slightest amount of heat formation, we've got ether as our solvent. And since ether is our solvent and it's got a low boiling point, we should see that boil pretty readily. Once we see initiation occur, we're going to then keep that reaction going by adding the rest of our solution, but in a dropwise form. So we're not going to do that yet until we see initiation. Sometimes it can take a while, but patience, patience, patience. So this is initiation. So we've got our color change. It was yellow, now it's kind of a clear gray. And we'll see this color start to evolve as well the longer this initiation goes. So what's the initiation? This is the process where your magnesium zero is inserting into your carbon halide bond. You see it's very exothermic. If I can touch it, right? It doesn't have to be super hot for our ether to be boiling, but it's warm enough to where our ether is boiling. You start seeing the color change and darken a little bit more. And we should eventually see evidence of the vapors coming up from our round bottom and hitting the cold condenser. So once we start seeing this dripping coming down from our condenser, then we know that we have a good reflux going. Now we'll want to keep this reaction going, remember, and start getting even more. Remember, we still have some of our bromobenzene to add, so we're going to now add that dropwise. Our bromobenzene solution has added, so I'm going to close this stopper on our separatory funnel. And in the meantime, while this initiation is still proceeding, I'm going to make up our solution of our electrophile. And that is going to be our methyl benzoate. So this is what our Grignard is going to add to. And we're going to measure out our volume using this 1 ml syringe here. Be sure to share that calculation in your notebook. My methyl benzoate into my separatory funnel. And again, we're going to make that a solution so it's not so concentrated. And I'm just going to, again, use about 5 milliliters of my ether to make that solution. I'll give it a little mix. And we'll be ready to add that after our Grignard is formed. So I've poured the ether layer into just a clean beaker, and the odds are anytime you separate your organic layer from an aqueous layer in a separatory funnel, odds are you've got some water that has not been totally excluded from our organic layer. So what we need to do is we need to add our drying agent, and the drying agent is going to work to pull out any water that is remaining in that organic layer. Now typically, remember, if you can see water in your organic layer, then you've got too much in there. The drying agent doesn't work to pull out that amount of water. It's pretty much just any kind of microscopic water. And typically, water that's been left in the organic layer is indicated by cloudiness in the organic layer. Here we don't really see that, but it's typically always used as a last step after you do a separation from aqueous. So once the drying agent has done its job, then we filter it out, and the drying agent will stay up in our glass funnel, and our clean water-free solution will run down to the bottom into the beaker. Crystal formation. We've got our solution cooling so that we maximize our crystal formation. We've got our crystals coming out, and we're going to collect those by vacuum.